The question is, a set contains 5 elements. If the number of ways to construct 3 subsets of this set with replacement is n, then which of the following is correct? And we have been given options with conditions in them. So first of all, we'll just have a dummy set with 5 elements, 5 different elements. We don't care what these elements actually are. So I will just say these are 1, 2, 3, 4, 5. And the subsets, those will be A, B, C. So I have named them, and that means that if two subsets are equal, that also works. That is still a way to distribute the elements. So we want to make subsets A, B, C from the actual set S, and the first option says if the subsets have exactly one common element. All right. So first of all, we'll choose which element we want to be common. So for example, you could have 5 as a common element, you could have 4 as a common element, and so on. So 5 ways of doing that. Next, we need to understand what the element being common actually means. So it does not mean that no two sets can have the same element other than the one that we already have common. No, it means that all 3 of them must not have the same element. So for example, A being 5 comma 4 and B being 5 comma 4 but C being 5 comma 3, it works because 4 and 4 those are only common in A and B, right? C doesn't have 4, and that means 4 is not common with all 3 of them. So that's what actually this question means. So at first I was confused what it actually means. Is this pairwise common or common in total? It's common in total, in fact. So 5 ways of choosing the element that we want to keep common. Now for the other 4 elements, each of these element has some options. So either it could go to none of these sets. So the way to do that is just 3C0. So that element not choosing any of these subsets to go into, that is 3C0. Or it could go to one of these subsets, so that would be 3C1. Or it could go to 2 of these subsets, which can be done in 3C2 ways. Or it could go to 3 of them, but that's something that we don't want. So no, that won't be there. And this is for each element. So each of these elements will have all of these choices, right? But how many choices are actually over here? It's just 7, right? So find the 7 to the power of 4, because 4 elements are remaining, and each of them have each of them has 7 choices, and that's why 7 power 4. Now if you calculate this thing, this is what, 5 into 49 square, so that's like 2500 minus 100 plus 1, so 2401, and that times 5, that is 120. That 0 was remaining over there, and then 5, so 12005, and that's why A is correct. Let's go to B. So n equal to 3430 if union of these 3 subsets contains 3 elements. Alright, so first of all, we'll just choose 3 elements which will be in the union. That can be done in 5C3 ways. Next, we want to distribute these 3 elements into our subsets. So once again, what kind of choices does each element have? So either it could go into 0 of these subsets, so none of these subsets, but that's a wrong thing to do because we want that element to be in its union, right? To be in the union of A, B and C. That means it has to be in at least one of these sets, and that means 3C0 is not what we will include over here. We'll directly go to 3C1 and then 3C2, and now 3C3, because it can also be in all 3 of them, right? It's gonna work, right? So that is, well, let's see, it's once again it's just 3 plus 3 plus 1, so it's 7 to the power of what? To the power of 3, because now there are 3 elements which we want to distribute. So then this quantity, well, 5C3 is the same as 5C2, and that's 10. So 10 into 7 cube, that's 343, I think. So it's going to be 3430, which means option B is also correct. Option C is n equal to 1024 if these subsets are pairwise disjoint. Alright, so these being pairwise disjoint, that means that only 3C, no wait, yeah, 3C0 and 3C1, those are the only things that could happen, because it cannot, one element cannot go to two subsets or three subsets, right? So 3C0 plus 3C1, yeah, exactly, that would just be 4, right? So 4 to the power of 5, I think, because there are 5 such elements. Yeah, in that way you can just generate ABC, and this is the same thing as 2 power 10, which is 1024. Yeah, it's a nice number to remember. So that means C is also correct. Let's go for D. So n is 8 power 5 minus 1 if none of these three subsets is empty. So if none of the three, so first of all, what's the number of ways to actually make these three subsets? Well, each element, it has 4 choices, right? Yeah, because no sorry, yeah, it doesn't have 4 choices. It has 3C0 plus 3C1 plus 3C, that kind of, yeah, so figuratively 4, but you get it, right? So that would just be what, 8, so 8 power 5. Now of the three subsets is empty, right? Yeah, so 8 power 5 is the total number of ways to distribute, I think. Yeah, this makes sense, I guess. Or you could also go for yeah, you could also look for what's actually happening to A, B and C and not what's happening to the elements. So for A, you could either have 1 in there or not have it in there. So there's 2 choices for each element, just considering A, and then 2 power 5 for just A, but then it's B and C over there as well. So 2 power 5 times 2 power 5 times 2 power 5, which means yes, we are guaranteed that it's actually correct, because in 2 different ways you got the same thing, it has to be correct. So 8 power 5 ways of actually making all of these subsets, but the cases where at least one of these being empty, what's the number of ways that could happen? So 8 power 5 minus 3, why 3? Because you want to choose one of them which will be empty, so it's basically just inclusion exclusion, right? Yeah, all right, into, so if one of them is guaranteed to be empty, that's what we are doing, right? Then the other two can be filled in how many ways? Well, then each of these elements will have, I think, 2 power 2 in this case, which is 4. Yeah, that makes sense, because 2C0 plus 2C1 plus 2C2, so it has to be 4. So it's 4 power 5 because 5 elements, right? But plus, so plus 3 into this 3 is actually 3C2, this thing is 3C1, all right? So plus 3 into, so when 2 of these elements subsets are empty, and the third one will contain all of the other stuff, it's not empty. Yeah, I mean, it's not empty, we think it won't be empty, but in that case it can also be empty, because we will also consider those cases into here. So this will be now 2 power 1. Oh wait, this is wrong, that was 4, because, oh yeah, 2 power 1 is 2, and then 2 power 5, so that 2 to the power 5, and then minus. So what happens if all 3 of them are empty? And that's just 1, right? One way of having all of them being empty, exactly. So this will be the number of ways of distributing if none of these 3 subsets is empty. Right, this looks good. So this is clearly not 8 power 5 minus 1, because it has this thing over here which is not 0, so it's not correct. So D is not correct, A and B and C are correct, right? So I'll see you guys in the next video.